I hope I can maybe answer the question that, or comment that was made just a minute ago about getting bad answers from AI when you particularly want to ask about specialized information, because there are ways that you can address that, and that's what I hope my presentation will talk about. There we go. So I've been a time nut, one of the people who are really interested in precise time and frequency measurements for many, many, many years. And we have a lot of material available to answer questions. There's a mailing list called Time Nuts. It's got about 1,800 members, and it's been going for more than 20 years. There's 110,000 emails in our archive from that mailing list, all public information. There also are thousands of published papers. National Institute of Standards and Technology Time and Frequency Division has over 3,000 documents in their downloadable archive. There are other annual time and frequency forums where there are papers published and presented. So there's thousands of those available. Also, several of us have websites that have the results of our experiments and measurements. And so the question was, could we combine all this information together to make an expert system that would let you ask questions about time nutty things and get answers that are not hallucinations? And I started on that project. So first, just a little bit of background. What's an AI and what's an expert system? Well, most AIs, at least the ones that we're talking about most today, are based on a large language model. And you can think of that as being the world's most powerful autocorrect tool. What an LLM is really nothing more than a set of data that's been trained to know that if you type the word hello, the next word that's likely to follow, if you're a programmer, is world. It might be Bob or Jim or Sally if you're somebody else, but the LLMs predict what token or word is going to come next based on all the tokens that have come before. And from that, it keeps building the answer out as you go. And that's great as long as the predictions hold. When the predictions don't hold, you get these ridiculous results that are called hallucinations because the prediction model fails. And AIs that use LLMs are generally trained on a general set of data. It's pretty much everything on the web, but some of that's garbage, some of it's good, and the AI can't really tell which is good and which is bad, so it goes down these wrong tracks. So that doesn't make it very useful for answering specialized questions in a technical area. So what we want to do is come up with a way to add the domain knowledge that will allow it to generate accurate answers. Now, the first presentations talked a lot about training. And yes, if you have a huge amount of data, you can train an LLM to give you better answers based on what that data would indicate. But the problem is that takes a huge, huge amount of data to be able to make that work well. There's a different approach to doing that. And that is you use a knowledge base that contains these email messages, PDF documents, and all the other information. And you create what's called a retrieval-augmented generation. And that is where you ask the general purpose LLM a question, but when you ask the question, you say, hey, here is some context information that might help you answer that question, and you feed it the documents from your knowledge base that have relevant information. So the query might be, what's a crystal oscillator? So we go out now and search our database and get 50 or 100 documents that talk about crystal oscillators. And using various semantics and complicated algorithms, we find the most relevant 10. That's a random number. It could be other numbers. We take those 10 most relevant documents, and then we go out to the LLM, the ChatGPT or whatever, and say, hey, what is a crystal oscillator? Here are 10 documents with information that might help you with your answer. And the LLM then uses that and can generate an answer that has some valid information guiding it. And that is how you can get expert results out of a system without having to have a totally custom language model that might cost millions or billions to create. This is a picture of that process. It's a little bit of a word chart, but it starts out at the lower left. You start out with your documents. So I'll just focus on our PDF files. I downloaded about 3,000 PDFs from NIST and other organizations, Hewlett-Packard application notes, equipment manuals. We have to make those usable, so I scanned those, used an AI that Google makes available to convert them into text. So all these PDF files got turned into text documents, and the text documents then are chunked up into pieces of, it turns out to be about 400 words, and each of those chunks then is fed into a database after looking at its semantic content, which is something I don't fully understand, to be honest, but you take this 400 words, feed it into a model that compares what those words are, how they relate to one another, and comes up with a set of vectors. In the case of what we're using, 1,000 dimensions that indicate the semantics of that chunk of text. That vector goes into the database. When I ask a question, my question is converted into a similar vector. Now the database looks, what are the answers in the database that are closest to, in semantics, to the question that is asked, and it returns those results. Then those results are combined with the query. It goes to the large language model. The large language model synthesizes from the context and its own knowledge and gives me an answer. And it's really kind of amazing. I have a very short demonstration that I'll show in a second that shows the way the query process works. Now, how do you build this thing? And that's the other AI part of this. I have done some coding, hacked around, and I'm really good at syntax errors in C. I'm almost as good at syntax errors in Python, but Python's what seems to be the language that people use for this type of programming. But I could never generate the code to do this because 4 months ago, I didn't know what RAG was other than something that was in the laundry bin. So I literally went to an AI to tell me how to write the code. And after I was about 3/4 of the way through this process, I learned there's a name for this now. It's called vibe coding. That's the newest computing industry buzzword. And it's essentially where you ask an AI to write code for you. And I went in and said, I want to write an expert system, help. And I got some answers back about kind of the architecture, and then said, okay, well, write me some code. And it wrote the Python, and it sort of worked, but it wasn't great. And I said, well, fix it. And it fixed it, and we iterated. And at this point, I've got about 10,000 lines of Python, and about there's 20 or 25 separate code modules. I have looked at it, I've edited within it, but essentially all the code in the application was generated by AI, and it works. So an aspect of AI is, apart from using it to get useful output like this, is using it for coding. And again, I might have been able to write something given months and months and months, but this process literally took me 2 months. Now, I'm retired, so I could work at it harder than I ever did at my real job, but I was able to get this thing up and running in a couple of months, and it seems to be relatively reliable. It looks pretty, so it really worked well to do it that way. And one thing that I noticed is the AI knew about lots of libraries and frameworks and things that I had never heard of. So just generating a web page with the interactive chat kind of format, there's a thing called Streamlit that does that. And I had never heard of it. I would never have known about it. I didn't know what vector database to use. So the AI, in addition to just cranking out code, really helped with the architecture and the design. So it's something to consider. I think these days, AI coding is not going to replace code, but it can sure make it a lot easier to get things up and running. And if you're a good programmer, you can have it do the starting point, and then you can make it much better yourself. So the end result of what we put together was programs that I wrote well, the AI wrote, to take each of the three types of collections, the 110,000 emails, at this point about 3,400 PDF files, and 6 websites, and convert those into chunks of ASCII text, feed them into the vector database. We use a thing called ChromaDB. There's also a full text database so that you can search for actual keywords as opposed to just the context. We wrote the RAG server that provides that front-end interface to the database, and then the chat server that you use to enter your query. It sends it off to the RAG server to get the context documents, then sends everything else off to the LLM to get the result, and a bunch of other text and testing programs and utilities, all in Python. Everything's open source. And I said it's around 10,000 lines of code right now. I'm sure that a good programmer going through it could reduce the lines very significantly. There's a lot of unnecessary stuff in there, but a lot of it was there for testing. So we're going to try to do a demo, but because of the technical issues, I'm going to go to my last 2 slides first and then come back to the demo. So I just want to mention that there's lots and lots of AI involved in this. I used AI for code generation. I mainly used the Claude Sonnet model, which is really, really good at writing code. Some of the LLMs are really awful. Google's Gemini 2.0 Flash, which is free and cheap and very, very good for a lot of things, cannot write a simple bash script to sort a directory. It's just utterly awful at coding. So it's really important to find the right language model to use for the text, for the task. For PDF to text conversion, Google's Cloud Vision AI, it cost me about $100 using their API key to do over 3,000 documents, OCR scanned, so not overly expensive. The database embedding was done with an open source embedding model called BGEM3. Then the model that ranks to find the most relevant documents was another open source model called BGE Re-Ranker. And then finally, the thing that generates the answer for you goes out via Google's API using the Gemini 2.0 Flash. So there are actually 5 different AI systems involved in creating and running this system. And some full disclosure, yeah, it wrote the code, but I don't think it would have worked if I hadn't been able to go in and read the code, see what was going on, find out why it wasn't working, and helping the AI learn how to fix the problems. So you need to have some technical knowledge, but you don't need to be a genius programmer. Yes, yeah, sometimes more than you want. You have to pick the right LLM. The Claude Sonnet 3.7 is really good. Google Gemini 2.0 is really bad. There are some length limits, context limits that can be a problem, and I'm going to move real fast. This last thing is, if you want to play with AI, you can go to ChatGPT, and their account is like $20 a month. There's a thing called T3.chat, and there's a free tier for low-level use, but for $8 a month, you can get unlimited access, and it gives you about a dozen different LLMs that you can try, and it's a really fast, nice user interface. So I'd highly recommend T3.chat. I won't go into these decisions, but there are some issues about what you do locally, which requires using a graphics video card versus what you might host remotely.